Hello, hello, welcome, welcome. All right, so lesson 29 for solving radical equations. Okay, so this is a new lesson that we're gonna take. It's gonna take us a few days to fully get. I'm not gonna lie, once it gets to these questions, life will be very difficult. All right, so be prepared to do some high level math. Okay, so let's just begin. Learning intention is to develop a deeper understanding for solving radical equations. The essential question is, which techniques are needed for solving radical equations? Okay, so throughout our whole year together, we've been developing a lot of techniques. And how do you know when to use them and how to use them? Those are important things that we need to develop. Okay, so as kind of like a little do now question, just to warm up with this concept, without even looking at this, just even before we get to this question, there's a little bit of a warm up I'd like for us to do before we fully understand what's going on. So let's look at this. And remember, Cornell note setup. If Carlos and Andrea were solving the equation x squared plus 2x is equal to 0, right? Andrea says that there are two solutions. X is equal to 0, x is equal to minus 2. And let's say Carlos says that there's only one solution, x is equal to minus 2. All right? And the question I have for you is, who is correct and why? Or maybe they're both wrong. But take a few minutes, try and figure this out for yourself. If I give you this equation and I say, which values of x make this true, figure it out. Is it just these two? Only this one? Let's see. Alright, so let's say if you want to come back and solve the question, let's see how Carlos did this question. If Carlos says that there's only one solution here, my guess is that, my guess is that what Carlos did over here was he divided both sides by x. And now, what did he get? He get x plus 2, right? Because x squared divided by x is x, and 2x divided by x is 2, is equal to, well, 0 divided by x is just 0, and then you do minus 2, and x is equal to minus 2, okay? And if you plug in minus 2 into the original equation, negative 2 squared is 4, 4 plus 2 times minus 2, 4 minus 4 is 0, so that works. But here, what Andrea did was she factored out an x, and she got this, right? And she said, well, here, x is equal to 0, and x plus 2 is equal to 0, so x is equal to 0, and x is equal to minus 2 is also a solution, okay? So here, Andrea was correct because even though, let's see, did Carlos break any rules in math? He didn't. He just divided both sides by x, and he got x is equal to minus 2. But why was Andrea able to get another solution? She was able to factor. And here, when Carlos factored out the x, when he divided the x, he didn't get this solution. But x equal to 0 also works because 0 squared plus 2 times 0 is equal to 0, so that works. So here, let's look at this. Do both 0 and negative 2 satisfy the equation? Absolutely. What happened when Carlos divided both sides by x? Here, Carlos, he lost one of the possible values for x. Okay? And what does this say about the solution of equations when performing algebraic operations on both sides? Be careful. Be very careful. Be very careful. Alright? So let's see. Let's move on. Okay. Now, let's say Carlos and Andrea are now solving this equation, right? It says square root of x is equal to minus 3. And Andrea says x is equal to, that's a 9, not an a, is equal to 9 because she squared both sides, right? I'm guessing this is what Andrea did. Andrea has square root of x is equal to minus 3. I square both sides, right? Square root of x squared is x. And what's minus 3 squared? That's 9. But Carlos says no solution. Carlos says there is no solution for this equation. who is correct and why. So I'd like you to do is take a few seconds, take a few moments, and see which one, see what happened. Okay. Let's go through the questions here. It says, was Andrea correct to square both sides? Absolutely, right? If I say solve for x, get x by itself, square both sides, x is equal to 9. So is she correct that the solution is x equals 9? Well, the thing is, if you say x is equal to 9, we have to check it, right? So if square root of x is equal to minus 3, x is equal to 9, square root of 9 equals minus 3, this is not true. Square root of 9 is 3. And now a lot of you are probably thinking, oh wait, mister, hold on, wait a minute, square root of 9 is equal to plus or minus 3, right? Because I could say 3 times 3 is equal to 9, and I could also say minus 3 times minus 3 is equal to 9. And that is true, but whenever you're taking the square root of something, unless you have a negative symbol here, you see, when you have the negative symbol here, like if I say square root of 9, this is equal to 3. But if I say negative square root of 9, what this means is you're taking the negative root. You're getting the negative root out of this. When you have just square root here, you're taking the positive root out of this. Okay? This is very, very crucial. Okay? If there is no negative symbol, if it's just positive, if there's nothing here, then you're taking the positive root. You're not taking the negative root. So this is 3 is equal to minus 3. This is not true. It is no solution. So Carlos was correct over here. And what I'd like you to have is here, whether or not you're going to do the Cornell notes and that setup, that is up to you. But if I have a little star over here, this is a very important question. So here, what is the danger of squaring both sides? What is the danger of squaring both sides? Here, we did get x equals 9, but when we plugged it into the original equation over here, one side did not equal the other side, so this is false. And this x is equal to 9 is an extraneous solution. Okay? It's an extraneous solution. And just to kind of go back a little bit on this, if you don't have the definition for extraneous solution in your notes, I have it, where do I have it? Ah yeah, over here. I have it over here. So please have this in your notes if you don't have it. But an extraneous solution is a solution to a transformed equation. So here, what did we do? We had this and we're transforming. We are also manipulating. You're manipulating the equation. And here, x does equal 9. It satisfies the transformed equation, but it's not a solution to the original equation. So you see, we did transform it to x equals 9, but when you plug in 9 to the original equation, it's not true. So this is an extraneous solution. All right? So what is the danger of squaring both sides? You could get extraneous solutions. All right? And now here, let's look at question number 7. These are nice questions to help guide you. Because of this danger, what is the final essential step for solving radical equations? Oh God, whoops, sorry. Okay. Here, because of this danger, what is the final essential step for solving radical equations? It is always to check your work. You have to check for extraneous solutions. Always, 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 always. Okay. There we go. Now, let's look at this final question for this video, and then I'll do part 2. Here it says, how could we have predicted that the equation would have no solution? Like the question here, we had square root of x is equal to minus 3. If we have, if we're trying to develop a deeper level understanding, right? This is the learning intention, to develop a deeper level understanding for solving radical equations. Here, square root of x is equal to minus 3. This won't be possible because remember here, when I said here, when you say the square root of, let's say, 25, and there's no negative here, it's just positive, you're always taking the positive root. So here, square root of x, it can't be negative because you're not asking for the negative root. And this, please have in your notes, the square root of a number is never equal to a negative value, ever. So if I have square root of x is equal to a has to be greater than 0, meaning a is positive. But for example, if I have square root of if I take the negative root, then this is equal to minus a. And that's true. This is okay. But here we don't have that. So that's why we could have predicted that the equation would have no solution. Okay? That's a deeper level understanding. All right. So this is a nice 11-minute warm-up. And we didn't even get to the actual packet. We didn't actually get to the actual lesson. And that's going to be in part 2. Okay. I will see you.